Hello, everybody. Welcome back to another video. In this video, we're going to be taking a look at a topic from organic chemistry HR, which is synthetic roots. Now, this is probably my favorite topic across the IB chemistry syllabus, simply because it has so much real life application in it. So many of the times, especially in chapters like organic chemistry, you may be thinking while doing certain topics like SN1 and SN2 reactions, or free radical substitution, or learning all these different types of organic reactions, you may be wondering, why or where am I ever going to use this in my life? And even I have asked myself this many times. And in synthetic roots, this is exactly what we do. They're teaching you where you're going to use this in your life and how it all ties in together. And it's really a very beautiful chapter. I had so much fun when we did it in class. I still remember it. Unfortunately, we didn't spend too much time on it because it's not a very big chapter. But in summary, this chapter is the application of everything you have done before. So all the different types of reactions you have learned, everything is applied over here. And you don't learn anything new, you just see how it all ties in together, how you can apply it in your life or even at your job if you choose to go into the chemical engineering industry or the pharmaceutical industry or any industry which involves you to manufacture certain chemicals. So let's take a look at it. Now over here, I have this big graph or a diagram of sorts, kind of looks like a food web. From different chemicals, there are arrows. What's going on over here? I know you must be a bit confused, but don't worry about it. I'm just going to pick one chemical, and I'll show you what basically is going on. So, okay, let's pick this one. We have over here. This is a aldehyde. So this aldehyde, when we add or when we reduce this, when we reduce this aldehyde, because NaBH4 is a reducing agent. And when we use methanol, we basically get an alcohol. There we go. And then from this alcohol, if you want to convert it back into this aldehyde, well, you have to oxidize it using an oxidizing agent, and then you go back to this. But if now you have this alcohol, if you want to convert this alcohol into an ester, for instance, well, you have to first combine it with the carboxylic acid, as they have shown over here, and you have to put in a few additional ingredients like heat and concentrated sulfuric acid. But if you want to get this alcohol over here, alcohols are used in the industry everywhere. And if you don't have an aldehyde, and if you want to make an alcohol, well, you have another option. If you have an halogenoalkane, well, you can just add NaOH to it and you get an alcohol. And if you guys know your organic chemistry reactions, you've studied this chapter well, you would know that this reaction over here where we add NaOH or sodium hydroxide to a halogenoalkane, this is an SN1, this is an SN2 reaction, my apologies. So this is an SN2 reaction. Oh, no, never mind. It is an SN1 reaction. Oh, what's going on with me today? So this is an SN1 reaction, not an SN2 reaction, because this is a secondary, it's a secondary, it's secondary halogen. Oh, so it could be SN1 or SN2. Wow, how we went through the whole process over there. So this can be an SN1 or SN2 reaction. How do you get a halogenoalkane? Well, you can get a halogenoalkane by using free radical substitution. I covered this in my last video where I spoke about free radical substitution. So if you have an alkane and you want to add a halogen to it, well, you need UV light, which is how you create the radicals. And the radicals are bromine radicals. And these radicals are very reactive. They will form halogenoalkanes, right? They will attach themselves onto the alkane. And then you can convert this into the alcohol. So how do you get this alkane? Well, you can make alkanes from alkenes. Alkenes are organic compounds which have one or more double bonds in them. So you can convert an alkene into an alkane using a nickel catalyst, heat, and some hydrogen. So this hydrogen will just come and will break this double bond and attach to each of the respective carbons to make an alkane. So hopefully you see what I have been doing over here. This is a chart of many different types of organic reactions. You go from one to the other, from another one to the other one. So basically, if you are a scientist, if you are in your laboratory, and if you have an alkene, right? If you have an alkene and you want to create an alcohol, or if you want to create an alkane, how do you do that? Well, this is your recipe sheet, right? You can make something like this. Diagrams like this will help you out. And all these reactions, these arrows represent the reactions. So all these reactions that we have, that you see over here, we have all done them in the previous chapters. Nothing new is being taught over here. So that's why if you want to do well in this chapter, it is very key that you learn all the reactions before this well. So like I said, this is the application of everything. And questions from this, I have seen them come up in a few exams, not very frequently, but they do come up. And where they do come, they are worth for at least 4 marks. So that's huge. That's a lot of marks. So make sure you learn this chapter well. Very easy chapter to learn, just the application of everything you've learned before. Sometimes it can be a bit confusing. You know all the reactions, but you just can't seem to connect the dots. And I completely understand that. That happened to me as well, and a lot of other students. But once you start practicing, everything gets so much simpler. It all starts to fall into place. But before you practice, remember, you must learn the reactions. All the reactions before this, you must learn them well. Otherwise, you're not going to be able to do this chapter. So just for practice, I have pulled out a question over here. And remember, this diagram and this question, these are all from the Cambridge IB chemistry textbook. It's my favorite IB chemistry textbook. And in fact, I'm in university right now. It's been my first week, and I'm using it still because sometimes you need to go over the basics and brush up a bit, and it's really very, very helpful. So I would recommend you to use that. You can find a link to the book, an e-PDF of the book on my Google Drive, and I can give you the link if you message me. And yeah, so this question, let's get to it. So there's a practice question. I'm not going to go through the entire thing. I'm going to kind of scaffold what you should do when such questions come up. I'm going to guide you through it. So, okay. Design a reaction pathway for the formation of a compound shown below. Use alkenes as the only organic starting material. So now, again, I want you to put yourself in the shoes of a scientist. You're a scientist, you are in the lab, you work for a perfume company, you work for Christian Dior, okay, they make good perfumes, or you work for Versace or some other company, your favorite perfume company, okay? And you are a chemist in their laboratory. You need to create this chemical over here, okay? It's used in perfumes. Now, what is this chemical? Well, if you know your organic compounds, well, this chemical is actually an ester. So this compound is an ester, and the giveaway is this right over here. Whenever you see this particular functional group, this tells you that it is an ester. So what are esters made up of? Well, esters are made up of carboxylic acids and they're made up of alcohols. Hopefully I'm spelling this right. So when you add alcohols and carboxylic acids together, you get esters. But what particular ester is this? Well, we can see that the alcohol in this ester, the alcohol is, this part is the alcohol. So the alcohol in this ester is propanol, because there are 3 carbons, right? So don't be confused. Don't make a silly mistake in identifying the compound. I've made that once or twice. Believe me, it's very frustrating. So the alcohol that is being used to create this particular ester is propanol. And what about the carboxylic acid? What carboxylic acid are they using? Well, there are 2 carbons in this carboxylic acid, so it's going to be ethanoic acid. Now, if you want a revision of all of these topics where, these different types of compounds, how to name them, how to identify them, please go and visit my previous organic chemistry videos. I've explained all of this in great detail, and everything you need is on my channel for this particular topic, identifying different organic compounds, what is signature about them, how do you name them, how do you identify them? Like I said before, it's all on my channel. So please go and help yourself to those videos. And I assure you, you will learn everything by the end of it. So do that. Anyways, let's continue. So the carboxylic acid is ethanoic acid. The alcohol is propanol. So we know what two products we need. We need these two products. In our recipe to create this particular substance, we need these two ingredients. How do we create these two ingredients? Well, they've told us in the question that our starting ingredients can only be alkenes. We can't use anything else. So first I'm going to create propanol, right? Using alkenes. So I need to create an alcohol from an alkene. If I have propanol, well, propanol has 3 carbons. So preferably my alkene should be propene, right? I'm going to start with propene. So I'm going to start with propene. So this is propene. And from propene, the first thing I'm going to do is I'm going to hydrate it. It's going to undergo a hydration reaction. Now, hydrate something, to hydrate yourself. What does that mean? That basically means to add water. So when I add water, this thing is going to become an alcohol, basically. So as you can probably see, H2O, right? We've added water to it. So H2O is made up of, well, it's like this. So this one hydrogen has gone and attached itself to carbon number 1. And then the OH has gone and attached itself to carbon number 2. And there you, boom, you have an alcohol. Easy, right? So there we go. We have our propanol. So simple, only one step. All we needed to do was hydrate our alkene. We have used an alkene. We've followed all the instructions. And we have got our propanol. So propanol check, we've got one part of our recipe. The next thing we need to do is ethanoic acid. How do we make ethanoic acid? Well, the first thing we need to do for ethanoic acid, we need to have a alkene, right? That's what they've told us. We can only use alkenes to start. Wait, I'm just going to erase this so I have some more space over here. Just give me a second, bear with me, I'm sorry. So I showed you in the previous step how to create propanol from an alkene. Now I'm going to show you how to create ethanoic acid from an alkene. Now ethanoic acid contains 2 carbons, right? Like we saw, it contains 2 carbons. So our alkene should also have 2 carbons. That means that our alkene, the one that we should use in the first place, should be ethene. So ethene looks something like this. Now, what is the next step? Now, this is a multi-step reaction. To create propanol, we only had to do one step, but for this, it's a multi-step reaction. This is where students get a bit confused, and even I did, but hopefully I'm going to teach you how to connect the dots now. Now, if you think back to all the reactions you have learned in organic chemistry in this chapter, you know that one way to create carboxylic acids is by oxidizing alcohols, right? When you oxidize an alcohol, first, it forms, and not just any alcohol. When you oxidize a primary alcohol, when you do that, first it forms an aldehyde. And if you continue to heat that aldehyde using an oxidizing agent, that aldehyde is going to become a carboxylic acid. We've learned that before, right? So if we know that, all we need to do is convert our ethene into a primary alcohol. So let's do that. Okay, how do we convert it into a primary alcohol? Well, I showed you earlier, what we have to do is hydrate it. So let's add water. When we hydrate it, this is what it forms. Now, it really doesn't matter where the OH attaches. It can attach to this carbon or this carbon, doesn't matter. Either ways, it's going to be a primary alcohol, because whether you count from the left or right-hand side, it's just 2 carbons, right? So it's going to be a primary alcohol in either case. Hopefully that makes sense. There we go. We have got our primary alcohol. Now we need to oxidize this under reflux. So you need an oxidizing agent, something like Cr2O O72 minus is a very strong oxidizing agent. You need some concentrated sulfuric acid. And the last thing you need is heat. I'm just going to put it down here. And this is under reflux. So when you do this, when you carry out this procedure, boom, you have got your ethanoic acid. We've learned about this, right? So simple. Look at that. We've already created our two ingredients. That's it. There you go. We have our two ingredients. We have ethanoic acid and we have propanol. Now all we have to do is combine these two, and there you go. You have got your ester. Now, where are esters used? Esters are used commonly in the perfume industry because they give you that the fragrance that you have in that you smell when you put on a perfume, that nice fragrance, that is actually brought about by esters. So esters are responsible for that. So many perfume companies all around the world, deodorant companies, they use esters frequently to give their products that nice smell, the reason why you put them on. So that's it for this video. Hopefully I've given you a taste of synthetic roots and how to approach this topic. Remember guys, in synthetic roots, you learn nothing new. All you do in synthetic roots, it's connect the dots of what you have learned previously. So if you want to do well in this chapter, you need to have a very good foundation of what you have learned before. All the organic reactions, all the different types of substances, all the different types of organic chemicals, you have to know all of them very well. Otherwise, you won't be able to do this. And oftentimes in exams, they will ask you to provide the conditions necessary for a reaction to take place. So for example, if you are doing this question in an exam, and if you are writing how to form ethanoic acid from an alkene, you have to specify what conditions are required, like I did over here. So I told you that water is required to convert an alkene into an alcohol, and then from the alcohol into the carboxylic acid, you need an oxidizing agent, you need concentrated sulfuric acid, you need heat. So you need to specify these conditions if you want to get the marks. So hopefully I've made myself clear. I would recommend all of you to study synthetic roots from this diagram. It's very, very helpful, and even create such diagrams of your own. Put yourself in the shoes of a scientist, pick an end product. Suppose you want to create, okay, let's just go with ester. You want to create an ester from an alkane. How do you do that? So make these mind maps, write down the conditions necessary between each reaction, like they've done above the arrows over here. These are the conditions. These are the conditions. These are the conditions. So write those down, and they will really help you out. I did that. So thank you so much for watching this video. That's it for this. I don't know how much I'll be posting from next week onwards because my university starts. I'm going to be pretty busy, but I will do my best. I'll try to post at least twice a week, but I'm always open for your questions. Thank you so much for watching. See you in another video with another question, and take care of yourselves. Goodbye.